Hello and welcome to another episode of Fun with Science, and where we give you the best approach to solve the problems that your professors and your teachers give you. Today we're going to talk about the nucleophile substitution in chemistry. This sounds like a lot, but it's actually a pretty easy concept. For example, let's imagine you don't have any alcohol for the party tonight and all the shops are closed, but in the lab, you have some chemicals and maybe you can do something there to have some alcohol for tonight. All right. So let's say in the lab you encounter, there's a substance called bromethane, something like this. Brom, right? And what you want to have is ethanol, alcohol, which would have this structure. Okay, so how do we get from here to there? Well, we use nucleophile substitution. So the way this works is you take the ethyl bromide out of your chemistry cupboard. And if you look at the structure of this molecule, it is basically structured in that way. This points to the front. That's one H. Here's the bromine atom, and here's another H, and here is the CH2 group, and actually CH3. Okay, right? So now this carbon atom has 4 substituents, as it should be. We have C, H2, HH, and CH3 is here. Okay, so now bromine is a very electronegative atom. So that means the 2 electrons that form the bond between carbon and bromine are dragged a little bit towards bromine, right? So we can acknowledge that by putting like a partially negative charge here, partially positive charge at the C. So now we use something like sodium hydroxide, which is a solution that has a lot of hydroxide ions. And what this hydroxide ion now does is, if you throw it together with the bromethane, it gets attracted to the partially positive carbon, right? Negative charge and positive charges will attract each other. So now what happens is that this oxygen atom will attack the carbon, and we get something like a intermediate that is halfway bound to the hydroxide ion and halfway bound to brome. And then HH and CH3, they're basically on like a trigonal plane, which you can imagine is something that stands here vertically to the room, right? Vertically to your direction. And now the HO group is pushing the bromine atom out. At the same time, these 3 ligands are going to basically push in the other direction, and you end up with this. And you see it here. So that's the alcohol, and that's how you make the alcohol for your party tonight. And that's actually called a nucleophilic substitution. I think a bimolecular nucleophilic substitution. substitution, nucleophilic, bimolecular, because two molecules are basically part of this, right? The HO ion that becomes like a new ligand of C, and then the bromine atom that is on its way out. We have it here. So, and now you just need to separate the ethanol from the bromine and put it into some water, vodka. There you have it. Have fun at your party.